Students, welcome to Alpha CA learning program mathematics class. Actually, we have started yesterday in previous session about parabola, and now parabola we have done two standard forms. One is here y square equal to 4ax we have observed, and what about here the diagram of y square is 4ax. We have taken this one as y square is 4ax, and thereby we have done the proof of this standard form also. And in this one actually we observed different terms in this diagram. From this one, what are our observations? One is here vertex, so this is here students vertex of the parabola, and next one this is the focus of parabola, then this is actually the directrix of parabola. Okay, like this here we have taken different values. Now from the same thing the other parabola also we observed, that means here just replacing x value by minus x when x is negative. Here all our x values are positive, that means the curve is completely towards positive direction of x axis. And suppose if you take y square is minus 4ax, then also we have observed actually the nature of the curve is like this. Okay, so this is here origin, and here all our x values are negative, so as to make here y square value as positive, right? And next one, the other observation is here after these two curves. Now you observe here this is second degree in y, first degree in x. Okay, one is second degree in y, first degree in x. Moreover, the curve is symmetric exactly about here x axis. Now not only these two actually, suppose if I take exactly the other one, that is nothing but x square equal to 4ay, understand? And what is the nature of these two curves? Observe students, these two curves actually here they are exactly images of one another with respect to the line y equal to x. So this is the known curve, this is y square is 4ax, and then x square is 4ay, means this is our x square equal to 4ay curve. Now if I take this is the line y equal to x, okay, so this is the line y equal to x, and all of you know clearly images with respect to y equal to x. So image of the point, right, image of the point a comma b with respect to the line y equal to x is nothing but how much? B comma a. So just reversal order we write it is nothing but b comma a with respect to the line, it is y equal to x is b comma a. Okay, so in this way if you observe whatever the values we wrote for y square equal to 4ax, all values just you take here, if it is coordinate wise they are coming, write it as b comma a. Let's have a glance on all these four forms. Understand? First one is y square is 4ax. In previous session already we observed this is the diagram, and vertex means exactly this one. What is the meaning of vertex here? It is nothing but the point of intersection of curve and axis. Okay, so this is axis, and here the axis is nothing but x axis. So point of intersection of curve with axis is nothing but vertex, and that value for this parabola 0 0. And next focus we deduced from the standard form, it is a comma 0, and next one is point of intersection of axis and directrix. So directrix is exactly this line, this is directrix actually. So here you can observe the point z, right, and that point z coordinates actually they are minus a comma 0. While doing the standard form, what we have taken, as equal to az equal to small a, right, we have taken SA equal to small a equal to AZ. In this way we have taken, and therefore here this is Z, whatever the distance between these two is A, and here also this distance also here A. Thereby you got the focus as a comma 0, and the point of here intersection of axis and direction, that means the coordinates of here z, understand, z coordinates, and that one is exactly how much here, minus a comma 0. Thereby we have taken equation of directrix is nothing but x equal to minus a. Okay, and then end points of latus rectum. So these are end points of latus rectum. Latus rectum meaning is what here? It is a double ordinate passing through which one here? Focus a comma 0. So if this is L, this is L dash, and now this is the curve equation and graph, and now these values are nothing but a comma 2a, and this is here a comma minus 2a. So latus rectum end points you got how much here? A comma 2a and a comma minus 2a. And next one is equation of axis. To this equation of axis means, what is axis actually? Axis is a line passing through the focus and perpendicular to directrix, right? So here the equation of axis is nothing but, it is nothing but y is 0 because it is x axis here. So y is 0. And next equation of directrix, we have observed this directrix equation, it is passing through minus a comma 0 parallel to y axis, therefore x equal to minus a. And tangented vertex, that is x is 0 because exactly at the vertex if you draw tangent here, that is nothing but tangented vertex, and here it is y axis, therefore its equation is x is 0. And next one is equation of latus rectum. It is nothing but x equal to a because latus rectum always passes through here focus. Now students, here you can observe clearly one point, very important case also, that is nothing but what is the relation between here latus rectum, tangented vertex, and the other part is nothing but directrix. So this is the directrix and this is our tangented vertex, right? Tangented vertex, and this one is our latus rectum. It is a double ordinate passing through focus. Now how are these three lines actually? These are actually parallel lines. Moreover, the middle one, this tangented vertex, is exactly equidistant from latus rectum and directrix because we have taken this is a and this value also a, right? And therefore we can say this is here tangented vertex always a parallel line lying midway between latus rectum and here directrix. Understand? Very important in problems also you can take care of this one. So latus rectum, tangented vertex, directrix, all these are parallel lines. Moreover, tangented vertex always lies in midway of these two lines, latus rectum and directrix. Okay, so this one is here our equation of latus rectum, that's why this is x equal to a, this is x is minus a, and whereas this equation is x is 0. Okay, so in this way we can make use. And focal distance, what is focal distance? Focal distance is nothing but here the distance between any point on the curve, okay, the distance between any point on the curve to the focus. So this is p here s value, and this one is q here s value, so sp sq. Like this if you take here and suppose p is x1 comma y1, then the focal distance value is nothing but mod of x1 plus a, right? And what all these values you have observed for y square equal to 4ax. Now just now I told you students, here y square is 4ax and x square is 4ay. These are actually images of one another with respect to the line y equal to x. Okay, and therefore basing on that you can observe these both are here same. That's why here also you got both are same. Whereas here you observe this is a comma 0, exactly this one is here 0 comma a. Because of what reason here? The image of, understand, the image of a comma b with respect to y equal to how much here? Y equal to x. Image of a comma b with respect to y equal to x is b comma a. So basing on this concept we can observe here y square is 4ax and x square is 4ay. So this is a comma 0 and this is here 0 comma a. Okay, and again here minus a comma 0 and here you got 0 minus a, right? And here a comma plus or minus 2a, exactly reversal order, plus or minus 2a comma a. Next one, these are equations, of course you know all of you. The equation for x square is 4ay. X square is 4ay if I write. This is our x square is 4ay curve, and this is horizon here, and it is our x-axis, this is here y-axis. Okay, and now whenever we have taken, this is always the vertex, and next one this is the directrix line. So directrix line, and now this is the focus. Okay, this is focus and coordinates of focus here 0 comma a, and directrix is nothing but how much? X equal to, but this is parallel to the line x axis, so here you will get y equal to minus a. And what about here? Latus rectum, that is y equal to a line parallel to x axis and passing through 0a, therefore y equal to a. And now the tangent at vertex, this one, the tangent at vertex is nothing but a line parallel to these two and lying exactly midway between them. That implies this is nothing but here y is 0. Therefore you got here equation of latus rectum, that is equation of axis you know. Now equation of directrix is y is minus a, latus rectum is y is a, and this one is tangent at vertex which is lying exactly midway between these two and parallel to these two lines, right? And in this way again you can observe here focal distance. Focal distance means if I take any point on x square equal to 4ay, okay, any point on x square is 4ay, then from this suppose this is x1 comma y1 and this is our focus 0 comma y1, right? Sorry, 0 comma a, this is our focus. And now if at all you want to find distance between these two, that is focal distance, then that value is nothing but here y1 plus a. Just here replace x1 by how much here? y1. So these two actually students, once you know about this one, okay, all these values, it is very easy to you to write the values from x square equal to 4ay, because the two curves are nothing but images of one another with respect to the line y equal to x. Understand? Moreover, here observe x square means even par. Even par means this value always positive. Throughout this one we have taken a value as positive. Okay, therefore x square is 4ay, a is positive, 4 is positive, implies y also must be positive. That's why the curve is coming completely above x axis where our y values are positive, right? And next one here you observe these two values, x square is 4ay, all the values we found. Therefore students, just if you know about this one, easily you can write these all values. Then what about here? Y square is minus 4ax, right? Y square is minus 4ax means don't understand here a is negative. Every time a value is positive. Then what about here? X is replaced by how much here? Minus x, right? That means everywhere you observe x coordinate replaced by negative. Here if a, then here it is minus a. And minus a here, this is a. And next value here a, this value is minus a. Of course plus or minus you got, therefore you can use here minus or plus, because you are going to consider minus a comma 2a as well as minus a comma minus 2a also. That's why here replacing a by how much? Minus a. And these of course those are same because axis is same, and that's why here these two will come same. And again here a is reflecting, wherever a is coming just replace that value by minus a. So minus a here, and now here it is a, and x equal to a here, x is minus a. Mod of x1 plus a, here you got mod of x1 minus a. So what is the only difference here and here students you observed? Replacing a by minus a. Understand? Rest all here same only. And again here x square is minus 4ay. You can observe here these two are actually images of again one another. Okay, so whatever values you got here exactly, if you take the order as b comma a, reversal order, coordinates reversal order, minus a 0, 0 minus a comma 0, 0 comma a, like that everywhere if you take the reversal order you can get here all the values from this point of parabola also. Okay, or else already you know about this one, then here replace again a by how much? Minus a here, minus a here, minus a here, a, like that you can replace a wherever a is there, minus a. Rest all other values are same. So these are a very important thing students, because basing on this actually we have to go for other concepts also. So far whatever 4 parabola models we have taken, these are exclusively when axis is exactly either x-axis or it is y-axis. Okay, here it is for coming as x-axis is our axis, whereas for this y-axis is our axis. So exactly axis is coming as coordinate axis, then we can take all these values. But that doesn't mean every time we can come across only these kind of parabolas. There may be different types of parabolas also. Now we will take one by one. One is nothing but here exactly the parabola whose axis is parallel to x-axis. And next we will consider a parabola whose axis is exactly parallel to y-axis. And later we observe wherever axis is neither parallel to x-axis nor to y-axis also. Okay, let us observe one by one. So students, so far we have observed 4 kinds of parabola where axis is exactly x-axis or y-axis. Okay, 4 types of parabola. One is coming as this side, okay, and the other one is coming as exactly the opposite side. And here what is axis? From these 2 parabolas, the axis is nothing but exactly x-axis. Okay, and suppose if I take this kind of parabola, okay, this parabola, here axis is coming as y-axis, and again here if you take this parabola, axis is exactly y-axis. Just now we have observed, and this equation is y square is 4ax, right? And this equation you got y square is minus 4ax. Now our interest is here at present we want to check here when axis is exactly parallel to x-axis. Okay, so here what is axis? It is along x-axis. What is the meaning of axis again? A line passing through focus and perpendicular to directrix. Okay, a line is passing through focus and perpendicular to directrix is known as axis. So here we have taken the axis as x-axis both the ways. Whether here a value always positive, students, only thing is all x values are positive, whereas here all x values are negative. Right, now how to find here when equation, that means here axis of parabola is parallel to x-axis. Then just here observe the nature of the equation is of this model. Y minus beta whole square is this one, or here it may be exactly minus. Moreover, how is the degree here? It is second degree, whereas the degree of x is here 1. Therefore, if you simplify completely, then the equation can take of this form also. That is x equal to ly square plus my plus n. Because you will get here only x, understand? And whereas you will get here, if you expand, y square term present as well as y term also present, moreover beta square 4a alpha constant term also there. That's why the equation can be of this form. So remember, parallel to x-axis means just x equal to, okay, parallel to x-axis, therefore x equal to ly square plus my plus 1, second degree in y, first degree in x, right? Now how we can find, in these cases, how can find the other values, that means focus, vertex, latus rectum, etc. Till now whatever we have observed, how we can get using these kind of equations. Now let us take here the equation. Suppose y minus beta whole square is equal to how much? You got 4a into x minus alpha. Suppose the equation is of this form. Here how is axis, students? It is parallel to x-axis. Then to this one, what about exactly the vertex, etc., all the values? Now here clearly we can say y minus beta whole square x minus alpha. So I am writing the equation as exactly y square equal to 4ax. Okay. So in this way I am representing by making use of the concept of translation of axis from change of axis. Okay. Therefore here what is the x value you have taken? X minus alpha, and y value is nothing but how much? Y minus beta. That's why I can say clearly this is a parabola where axis is exactly here along x-axis. Once you shifted the origin to the point, which one here? Alpha comma beta. Therefore, by seeing this axis of parabola whenever it is parallel to x-axis, how you came to know about this is exact equation because of this nature. Here you know y square is 4ax means already we have solved the standard form also, where axis is along x-axis, and whereas here alpha comma beta is the vertex, that's why we are telling it is parallel. That means what you are doing here, actually you are shifting origin to which point? Alpha comma beta. Okay, now I'll write here all the coordinates, but they are coming in terms of new system. Okay, first one, let us observe what is the vertex, right? So what about here? Vertex. Finally you have to reduce in old system. Okay, now this is the new system, capital X capital Y, but finally because this is the given equation, you have to reduce in old system. Even in problems also directly you can make use of this concept. So vertex, whenever it is given here, it is, you know, for this one x comma y is equal to how much here? 0 0. But what is x and y? Those are x minus alpha, y minus beta. Understand? If you convert in old system, it is x minus alpha, y minus beta is 0 0. And if I equate abscissa ordinate, then you can get here x comma y is nothing but how much, students? It is alpha beta. Therefore, we can say clearly vertex of the parabola is nothing but in this one alpha comma beta, abscissa ordinate. Okay, so in this way you can write here all other values also. And next one is here focus. Okay, so what is our focus formula? From the new system, actually I am taking this one as here a comma 0 to the standard form, right? And now again in the same way, if I write this is x minus alpha comma y minus beta is equal to, it is a comma 0. That implies x comma y, if you equate abscissa x minus alpha equal to how much here? A. Then x equal to how much here? A plus alpha. Therefore this is a plus alpha comma this value is beta. Understood here? And next one, the other, it is nothing but ends of latus rectum. So ends of latus rectum, first I am completing all actually points. Okay, ends of latus rectum. And what is our point actually? Capital X comma capital Y, because you are finding in new system. Okay, so this is here a comma plus or minus 2a. These are ends of latus rectum. That implies again these are x minus alpha, y minus beta. That implies it is nothing but a comma plus or minus 2a. Implies our old system value, it is nothing but here, if you equate this value and this value, it is a plus alpha, whereas the other one again ordinate, if I equate, it is nothing but plus or minus 2a plus beta. Okay students, so from here what is the main observation? So just you can catch here one point. That point is nothing but once the vertex, if you take alpha beta, understand the new origin alpha beta, whatever the old system formula you are having, these are all known for y square is 4ax. To these what we are doing, just to x coordinate I am adding alpha, to y coordinate I am adding beta. That's it. A plus alpha beta, a plus alpha comma plus or minus 2a plus beta. So once you know students about this standard form, all the values, then to this system simply what you are doing is write the old values as it is, and to that just add alpha beta. That means the vertex. Okay, just add alpha beta everywhere, and those are nothing but our complete required values. Okay, now let us observe what about the equation part. Equation part means here I have taken ends of latus rectum and all, and now equations. Equations mainly we require equation of directrix, right? And what is equation of directrix you are having? The equation of directrix is nothing but to this standard form, x is equal to minus a, right? So what is but x value here? That x is nothing but here x minus alpha. So whenever equation part is coming, understand, equation part is coming, wherever capital X is coming here, just replace x by how much now? X minus alpha. Understand, in previous what is our formula? X is minus a. Now what you are writing? Instead of you are writing x, you are writing here completely x minus alpha is minus a. So very easy once you understood here about the concept. And next one is equation of here latus rectum. What is our equation of latus rectum? X is equal to a. Now this is nothing but x minus alpha equal to to A. And next one is equation of here tangent at vertex. So what about here equation of tangent at vertex? Okay, so tangent at vertex. The equation of tangent at vertex, it is nothing but in the middle it is falling, so it is x is 0, implies here x minus alpha is 0. So in this way, whatever the question they asked basing on the concept, then immediately just here for coordinates, okay, for coordinates you write as it is whatever formula you know from this one, but to those coordinates simply add alpha, beta, that is vertex coordinates. And whenever equation part is coming, to that equation wherever x is coming, just replace x by how much here? X minus alpha. Suppose in equation you are getting y terms, then replace y by how much there? Y minus beta. That's the only thing we have to do, very easy. Once numerical problems are there, you can solve easily. But whenever equations are given in this model, okay, in this model, then better reduce that value as like this, thereby you can write all values easily. Okay, that means here what we have to take, this one ly square plus my plus 1 n, that value we reduce as here 1 is perfect square because second degree is in y. Therefore, we write second degree in y perfect square and first degree in this way we replace, and again we can make use of all formulae. So all these we can observe in problems when numerical values are given. Okay. So students observe now, axis is here parallel to y-axis. In previous one we have observed when axis is parallel to x-axis, now axis is parallel to y-axis. How we came to know exactly? It is nothing but this one is of the form x minus alpha whole square and equal to how much? 4a into y minus beta, right? That implies x square equal to how much here? 4ay. Okay, that's why we can say here for this parabola, you know, actually axis is here along y-axis. Okay, so this one is the parabola, axis is along y-axis, whereas here how the axis is coming, it is coming exactly parallel to y-axis. Okay, now once the axis is falling parallel to y-axis, then what about here the other results? Just now we have observed, students, what is x here? X minus alpha and y equal to y minus beta. Okay, now these are the values we can write from this data. Then again from all values we want, that is vertex. Actually for new system, what is vertex here? X comma y, it is equal to 0 0. Okay, for the new system, that implies this is here x minus alpha, y minus beta equal to how much? 0 0, and hence I can say here x comma y, converting in old system, this is nothing but alpha beta, converting in old system. Okay, and then value of focus. Focus again for this one x comma y equal to this parabola, the focus is nothing but 0 comma a. Okay, that implies here x minus alpha comma y minus beta is equal to how much here? 0 a. Implies what about here x comma y values? These are nothing but it is alpha comma a plus beta. Okay, so in this way, students, whenever coordinates parts is coming, you just write the previous formula wherever x square is 4ay, standard form values, and to those coordinates you just add here vertex values, that is alpha comma beta. To x coordinate you add the abscissa vertex value, and to y coordinate you add here the ordinate vertex value. Simply that is nothing but here you can obtain all. That means here 0 is there, I added alpha, and a is there, I added here beta, that's it. Okay, and in the same way we can write other values also, that is here the focus you got, ends of latus rectum values if I write, those are nothing but actually a comma, but here what are those values? Just reversal order, plus or minus 2a comma a. Okay, so this one, then if I use here just add alpha here, beta here, that is alpha plus or minus 2a and beta plus a. Okay, so in this way you can write about ends of latus rectum. And again equation part, equation part as it is, we say here first one is equation of directrix. What about here? Directrix equation. This is our parabola here. Now directrix means it is coming here parallel to x-axis. That implies here, what is this equation? It is y equal to how much? Minus a. Now in terms of this one, it is y equal to minus a. But y is nothing but here how much? Y minus beta is minus a. That means equation part, wherever you are coming across, you just replace capital Y with what here? Y minus beta. So in this way, students, one by one values you can write very easily. And equation of latus rectum also, if I write here, what is actually latus rectum equation? This is our latus rectum which is passing through focus 0, a. So this is y equal to a, right? And therefore here y is a, but whereas in this one it is y minus beta equal to how much? A. And what about here? Exactly in between them, the tangentate vertex. This is our tangentate vertex, and that equation according as this formula, y is 0. And now that y is 0 is nothing but y minus beta equal to 0. So like that easily you can get all the values just if you know about the 4 forms, whatever tabular form just now we have observed. Then what about here? Simply the diagrams, roughly if I take you the diagrams for the previous one and this one. And here this is x-axis, y-axis we have taken. And now when origin is shifted, parabola is coming, axis is parallel. That means the parabola can be like this, okay? So parabola will be open towards this one. This is y minus beta whole square equal to 4a into x minus alpha, right? In this model it will come. So this may be the axis or this may be the axis, or here like this the axis will come, students, and thereby this is the form here opening towards this one, but it is coming here axis, wherever you observe it is parallel to x-axis. And similarly if I consider the other parabola, that is minus, if you are getting, then the parabola is of this model, okay? That means it opens towards here left side. So like this the parabola can be anywhere it is, okay? In this way it is left side. And what about here? This model, that is x minus alpha whole square and equal to 4a into y minus beta. To that one easily you can say it is nothing but the parabola can be here like this. That means we can say it is vertical. In this way it can be anywhere, okay? And now what about here? Vertex, this part is exactly here vertex, understand? This is our vertex alpha beta. Similarly if it is minus is coming, then the parabola is taking up this model. That means downwards, curve is here completely downwards. So students, these are different forms of parabolas. So far what we have observed is here, when axis is exactly along x-axis or along y-axis, or axis is parallel to x-axis or parallel to y-axis. So next session we are going to do numerical problems basing all these concepts, okay?